Hello, and welcome to this episode of So You Missed Lab, where we make everything up. Today's lab is the Molecular Shapes Lab. Today we'll be building two types of models for the molecules on your data chart. Before we build the molecules, you should draw the Lewis dot structures in your data table. Once we build the models, use those structures to complete the remaining columns in the data tables. In the first kit, the styrofoam spheres represent the atoms, and the toothpicks represent the bonds, or shared pair of electrons. In this kit, the toothpicks are placed to minimize the repulsion of the electrons. This helps determine the three-dimensional shape. In the second kit, the different colored spheres represent different atoms. Black is carbon, white is hydrogen, red is oxygen, blue is nitrogen, and green is any halogen. There are a specific number of holes in each atom for how many bonds the atom should have, and the shape of the molecule is determined by this. The first molecule is hydrogen with the formula H2. In both of the kits, the hydrogen is the small white sphere. The second molecule is oxygen with the formula O2. From your Lewis dot structure, notice that oxygen has a double bond, so we will need two sticks to represent this. Next is nitrogen, formula N2. Notice from your Lewis structure that nitrogen has a triple bond, so we need three sticks to model the molecule. HCl is next. Methane is next with the formula of CH4. This is our first molecule that is larger than two atoms. With the styrofoam model on the left side of the screen, we will have to minimize electron repulsion and place the bonds as far away from each other as possible. Carbon is our central atom. We can place the first hydrogen anywhere. The second hydrogen must be placed opposite the first to minimize electron repulsion. The third hydrogen can be placed initially at 90 degrees to the first two. However, electron repulsion will force the two bonds away, with each resulting bond angle being 120 degrees. The fourth hydrogen must be placed on top, forcing the three bonds down into a three-dimensional shape with 109-degree bond angles. This shape is called tetrahedral. With the kit on the right, we don't need to worry about bond angles because the bond placement is predetermined. Carbon tetrafluoride is next with a formula of CF4. Carbon dioxide, or CO2, is next. Your Lewis dot structure tells you there are two double bonds. Remember, carbon is the central atom. Next is water with the formula H2O. The extra toothpicks are used to represent unbonded pairs of electrons. These unbonded pairs of electrons repel just like bonded pairs. Our next molecule is chlorine, or Cl2. Ammonia is next with formula NH3. Notice the unbonded pair represented on nitrogen, the central atom. Boron trifluoride is next with formula BF3. Notice on your Lewis dot diagram, there are no unbonded pairs of electrons on the central atom. This results in a different molecular geometry for BF3 than NH3. Phosphorus pentachloride is next with the formula PCl5. The last molecule is sulfur hexafluoride, or SF6.
All right, guys, looks like we've made everything up. Now it's time to clean up.